Hello, I'm Shota Yamanaka from Yahoo Japan Research. In this study, we asked the participants to intentionally change their speed accuracy bias when they performed a target pointing task. For about 3 decades, HCI researchers have developed efficient target pointing techniques. A well-known example is bubble cursor, which has been replicated many times. In typical user experiments to evaluate a novel technique, researchers compare the movement times and the error rates of the novel technique and the baseline. The focus of this study is the instruction given to the participants. The most common instruction is point to the target as rapidly and accurately as possible. We call this neutral. This is a reasonable instruction because balancing speed and accuracy can simulate realistic usages for PCs, smartphones, and tablets. However, the speed accuracy balance would change depending on the external situation and internal factors in the participants. Therefore, neutral is not the only realistic balance. To evaluate the effects of speed accuracy bias on the experimental result, we give 3 biases: first, neutral and accurate, and we evaluate if a novel technique outperforms the baseline. Probably, we can replicate that the novel technique is better under the neutral condition, because this is the same instruction as in the original study. But we may reach a different conclusion under the first or accurate condition, such as no significant improvement in the error rate. This methodology to vary speed accuracy biases has been used in previous studies. However, the objectives were to evaluate the performance change, throughput invariance, and fits of it. In contrast, we assume that varying the speed accuracy bias is useful for evaluating pointing facilitation techniques. We can gain more informative results than using only one instruction, and we can discuss the advantages and disadvantages of the technique more precisely. We conducted 2 replication experiments. The first one was to evaluate bubble cursor. Almost all experimental designs were consistent with the original studies, such as the number of participants, target distance range, and target width range. The participants performed the task using both point cursor and bubble cursor under the 3 biases. The results showed that bubble cursor had significantly smaller movement times and error rates under any bias. This result rejected our assumption that we may reach a negative conclusion under the first or accurate bias. So we enhanced the effectiveness of bubble cursor compared with the conclusion in the original study. That is, even when users want to select a target more rapidly or more carefully, bubble cursor is a beneficial technique compared with the baseline. We analyzed the error rates in more detail. Under the first condition, bubble cursor showed significantly smaller error rates for the smallest and largest targets. But under the accurate condition, a significantly smaller error rate was observed only for the smallest target. This is a limitation. Still, under any bias, we confirmed that bubble cursor is a beneficial technique for small targets. Using multiple biases enables researchers to discuss such advantages and limitations. The next experiment is a replication of the Bayesian touch criterion (BTC). BTC is a target selection technique based on the touch point distribution. BTC computes how likely a user wants to select each target based on the touch point. Then, even when a touch point falls outside the intended target, a user can successfully select it. In this experiment, the participants successfully tapped the green target. The success or failure was judged on the basis of the visual boundary of the target at this stage. We used almost the same experimental design as in the original study, such as the number of participants, target width, and destructor layouts. The participants performed the task under the three biases. The results showed that the participants significantly changed their speed-accuracy balance according to the given instruction. The error rate data in this figure is based on the visual boundary of the target. Our question is whether BTC can reduce the error rates compared with other possible target selection criteria. We compared 4 criteria that were the same as in the original study. In addition, BTC has 3 variations depending on which parameters are used. As a result, a simpler criterion using the shortest distance between the touch point and the target center showed the best performance under any bias. Therefore, we always reached a different conclusion from the original study. Although we found a consistent strength of bubble castle in experiment 1, we reached a different conclusion in experiment 2 from the original study. If we had just replicated experiment 2 using the neutral instruction, this different conclusion might have come from our fault, such as that our participants didn't perfectly balance the speed and accuracy. However, because we tested the 3 biases, we can reject our concern that the simpler criterion using the target center distance was the best just by chance. To conclude this study, we showed that testing multiple biases enables us to gain more informative results than using only one bias. For researchers conducting a replication study, they would find a new limitation of an existing technique. They would find that the technique is effective regardless of the given bias, or they would always reach a different conclusion from the original study. This methodology is also useful for researchers who propose a novel pointing technique. They can claim that the proposed technique always shows a smaller movement time regardless of the bias, or they would find that the technique works well only when the bias is false or neutral. This enables researchers to write a defensive paper with more insightful results. This methodology is easy to apply because varying speed accuracy biases can be used with only oral instructions or text-based instructions. Our future work includes testing other biases, objective instructions, and other operation paradigms. That's all. Thank you for listening.